Question number 9. Here we are. It says here, they're giving us formulas, which is nice. They also give you these formulas in grade 12. So only, no, they don't. They only give you the addition rule. But this formula here, I mean, this is just universal. This one is specifically for independent events. But they said, yeah, formula you may find useful for this question. Two events, event M and N. They said, consider the Venn diagram above and use it to determine the following. So you have to remember, this is saying event M, right? There's the chance of event M happening on its own is 33 out of a total of everything. The chances of N happening on its own is 20 out of the total of everything. The chances of M and N happening together is 12 out of the total of everything. The chances of nothing happening is 15 out of everything. But let's start. The probability of M, right? This refers to everything to do with M. The probability of M is going to be the 33 plus the 12 divided by everything. So everything is 33 plus 12, right? Plus 20 plus 15. There you go. Now this, if you simplify it, you are going to get the following. That's what we get in our calculator here. Because in the calculator, you just have to make sure that you put in everything as best as you can. So at the top, we can see it's just going to give us a 45. At the bottom, 45 plus that, that's 65 plus that, let's give you 80. Obviously, you can simplify. 9 goes into, wow, it's kind of weird how 9 goes into what you call. 9 goes in here. I mean, 5 goes into each of them. 5 goes in there 9 times, 5 goes down there 16 times. There you go. Now this means or. This is asking the probability of M or N. When they ask for the probability of something or something, firstly, the probability of M would be all this. And then the probability of N, if they say the probability of M or N, what you do is you consider everything where M is, you consider everything where N is, you see. So here you're going to have the 33 plus 12 plus the 20. 33 plus the 12 plus the 20, the whole thing over 80. You see. So all this being done, you have 33 plus 12, which is 45, plus 20, which is 65. And then, now this you can just simplify it. The number that can go into both of them is obviously, again, just 5. 5 goes into 65 13 times, and then it goes into that one 16 times. There we go. For the bottom, it's asking what is the probability of M and N. You see. So the thing is, you have to keep in mind that and is inclusive. So this is asking where M and N meet, which is specifically just the 12. You see, that's the only part where you see M and N. So this is going to be a 12 over 80. 2 can go into both of these numbers. So you can have 6 over 40. No, you can go further here. 2 can still go in here. So it's going to be 3 and 20. There we go. 4 can go into each of these actually. So the smallest fraction there is just 3 out of 20. So let's see. B says M and N are independent or not. Justify your answer. This is where your theory comes in. For independent events, right? The probability of M and excuse me, the probability of N should be equal to the probability of M multiplied by the probability of N That's for independent events. This equation has to balance. So we want to test it out. So let's just put like a question mark here. When I test out if this equation balances out. So the probability of m and n, we have here 0. We have here 3/20. The probability of m, we have it as 9/16. The probability of n would be 32/80. So let's see here, 32/80. So in your calculator, you want to test it out and you want to see if it like balances out. If it does not balance out, it's not independent. So clearly it doesn't look like it's going to balance out. Like it's really not, it's just not. In your calculator, these don't balance out. So here you can say, therefore, not independent. Independent. There we go. Fantastic. So since these events are not independent, you can just move on to the next question, because if they're independent, these have to balance out.